Hello everyone, greetings again, and welcome back to MedZone African Motifs. So we're going to get into lesson 2 on series and parallel circuits. So in this lesson, we're going to look at what? Output devices. Output devices. So we're going to look at the output devices in electric circuits. So, okay, let us begin with a short explanation. So we say that light bulbs are not the only devices used in electrical circuits. Used in electrical circuits. So we say devices that use electrical energy. Electrical energy to function, including light bulbs. Are called output devices. So output devices, in short, these are devices that use electrical energy. Okay, so let us let me give you a formal definition here. A formal definition of an output device. No. Uh, so let's write it. So we say an output device. Okay. So an output device is something that is connected to an electrical circuit. An electrical circuit. It transforms the potential electrical energy in the cells and batteries in the circuit into another form of energy. another form of energy such as heat energy, sound energy, sound energy or sound energy or light energy. Light energy. So an output device is something that is connected to an electrical circuit. So it transforms, okay? It transforms potential electrical energy, okay? Into other forms of energy, okay? Other forms of energy. So what an output device does is that it transforms the potential electrical energy in the cells and batteries, and then it converts that energy into other forms of energy such as heat, sound, or light energy. So that's what an output device is doing in the electrical circuit. Okay. So let us look at what LEDs. So we're going to look at LEDs. So these are other forms of output devices. Okay. So this is an abbreviation for what? Light emitting diodes. Light emitting diodes. So the symbol has its own symbol, okay? So the symbol for a light emitting diode, there's a small rectangle like this with a line. Okay, so there are arrows that go out to show that this is a light emitting diode. So the symbol is like this. Okay, we show a light emitting diode like this in a circuit. Okay, so a short explanation here. So LEDs are widely used. LEDs are widely used widely used electronic devices. They are small, lights, but they do not have a filament. Like and so they not have a filament like an incandescent light bulb has. Light bulb has. So they therefore cannot burn out. Cannot burn out. So that is the advantage that LEDs have. Okay, is that because they do not have a filament. Okay, and so they cannot burn out. That is an advantage that LEDs have over other forms of light bulbs. See, remember, light bulbs in it, the symbol is like this for light bulbs. But then for LEDs, this is how we show it. Okay. So over here is for LEDs. So, okay, LEDs is another form of an output device, you see. So, okay, let us try to summarize what we've seen here in this chapter, okay? I want to make a nice flowchart diagram, okay? A nice flowchart diagram here that summarizes the chapter here. Mm. So this is series and parallel circuits. Series and parallel circuits. So what do we have? Series and parallel circuits. Okay, so let's say in a so the two circuits. Okay, so this side on the left we have a series circuit. So this mind map here. So this it will help you to visualize and to visualize the chapter to quickly. So this is a quick visual capture of the. So okay, in a parallel circuit, on the right here you have a circuit, and then on the left here you have a series circuit. Okay. So what are we saying? We're saying in a series circuit or parallel circuit, what is happening? Um, so we make a distinction here. So again, let's talk about pathways. Okay, the pathways of electric current. Okay. Um, so in a series circuit, there is only one. So pathway or pathways. Okay. So in a series circuit, there is only one pathway, and then in a parallel circuit, there is two or more. So there is two or more. So in a parallel circuit, there is two or more pathways. Here, there is only one. So, so we're saying that this side, on a parallel circuit, there is two or more pathways for, for current. Okay? So pathways for current. So there is for series circuit, there is only one pathway. There is only one pathway for current. So parallel, there is two or more pathways for the current. Okay. And then so again, we say current splits. So for a parallel circuit, current splits. Okay. Current splits between current split between current splits between branches. Okay. Between branches in parallel circuits. Okay. So current splits between branches. Okay. And so current is the same everywhere in a series circuit. So current is the same everywhere. In a series circuit, current is the same everywhere in a series circuit. So current does not split. Okay. And then let us look at something else here. We say that when you add, again, something else happens when you add resistors, okay? We know that in a series circuit, there is a decrease in current, isn't it? There is a decrease in current when you add resistors, and then there is an increase in current. So when you add resistors in a parallel circuit, so okay, let us begin this side, okay? So something happens when you add resistors, isn't it? When you add resistors, when you add resistors here, so when you add resistors in a parallel circuit, what happens? So we say when you add resistors in parallel, okay? So you add resistors in parallel, there will be, what will happen is that there will be an increase. You increase the current in it. When you add resistors in parallel, there will be an increase in current like this. So that's different. It's different for a series. So when you add resistors in parallel, there is an increase in current. That's what happens when you add resistors in parallel. So when we go the other side, okay, so this is for a parallel circuit. Then what about for a series circuit? Okay. Now, for a series circuit, when you add resistors, what will happen? So now, for this side, when you add resistors, what then happens? When you add resistors in series, in series. When you add resistors in series, so it's the other side of the so there will be what? There will be a decrease. There will be a decrease. So when you add resistors in series, I mean to say, you decrease the what? You decrease current. See, unlike the other side you increase, but here you decrease. See, so it's almost the opposite. When you add resistors in series, you decrease current. So this side, when you add resistors in parallel, you increase the current. You see the difference. And then what does this do? And then there is another thing that happens with regards to, so when the current increases or decreases, okay, when you increase or decrease current, and this can be done by adding the resistors. So it depends on whether the circuit is parallel or series. There is something that happens to the what? To bulb brightness. To bulb brightness. So now, okay, let's begin on the series side. What happens? So now, so for the series circuit, with regard to the brightness, there will be what? A decrease in it. There will be a decrease because the current decreases. So this means there will be a decrease in, so the brightness of the bulb, okay, which is a form of an output device here, okay? So we can observe, this is what we can observe. We can observe, okay? We can observe a decrease in brightness, meaning the brightness of the bulb. It will decrease since there is a decrease in current, okay? Because we said that there is a decrease in current. So there will be a decrease in bulb brightness, okay? So that is for a series circuit. And then for a parallel circuit, then you will have the opposite happening, okay? If we go the other side and we look at the parallel side, okay? So what then are we going to observe? Okay. there will be an increase in we're going to observe an increase in there will be an increase in so there will be an increase in bulb brightness. So this is what we can observe here. So then for a parallel, if we add resistors, then we can observe an increase in brightness. Because why? Because there's an increase in current. So guys, you can see that this is a what? This is a nice summary flowchart. It's a nice, so it's series and parallel circuits. So we say that in a series circuit, there's only one pathway. And then in a parallel circuit, there are two or more pathways for current. And then in a series circuit, what happens? The current is the same everywhere, okay, in a series circuit. And then when you add resistors in series, what happens? You decrease the current. And then you can observe a decrease in bulb brightness. You can observe a decrease in bulb brightness. Okay, now, other important thing here, okay? So we saw, so this is a nice summary with regards to a series and a parallel circuit here. So the other important thing here is that I should include in a summary of is that for series and parallel circuits, so this is applicable to both, okay? So series and parallel circuits can have, okay, um, they can have various output devices. Output devices. Various output devices. Yeah. So series and parallel can have various output devices, okay? Such as alarms, LEDs, and what? And motors. Um, Alarms, LEDs, and motors. So this is okay. So first, this various output devices are applicable to both circuits. You see, it's not just one type of a circuit. Okay. So this series and parallel circuits can have various output devices such as alarms, LEDs, or motors. You see. So let's leave it here for lesson 2. Okay. Let's leave it here for lesson 2. Thank you for tuning in. Thank you for tuning in again. Thank you for tuning in into Math Zone African Motifs. So we're going to do an activity in lesson 3. Okay. So I hope you tune in. I hope you tune in for lesson 3. So let's leave it here for now. Bye bye and take care.